Hello friends, welcome in this video. We all know that classic way of controlling a servo motor with a testing code, which is quite boring. But you can control the same servo motor with a very precise instrument, and that is called a rotary encoder, right? So in this video, I am going to show you that how a rotary encoder works and how we can control the servo motor with that encoder, right? So first of all, let us understand the working of the encoder and what are its pinout. So in this figure, you can see the rotary encoder consists of three pins, output A, output B, and the common pin C. Okay, this is a common pin. So what happens when we rotate the knob of this encoder, the output A and output B generates the digital signal. You can see this is a digital signal. Okay, and there is also a phase difference between the both of the signal. This is because uh, when we rotate the knob of this rotary encoder, there is a gap between both of the pins. You can see output A and output B, there is a gap. So when we rotate it clockwise, what happens? Output A comes in contact with pin number C first and output B later on. Okay. So output A leads the output B when we rotate it clockwise. But when we rotate it anti-clockwise, what happens? The output B comes in contact first with pin C, then output B comes in contact with pin C. So there is a phase difference because of this gap between output A and output B, right? So in clockwise rotation, output A leads output B, and in anti-clockwise rotation, output B leads output A, right? So this is how the working of the rotary encoder, and you can see the pinout of the rotary encoder. You can see in this figure, this CLK means clock line. So this corresponds to output A. DT means data. Okay, so this corresponds to output B, and the middle pin is for the switch. So what happens, you can either use the rotary encoder by rotating the knob or by pressing it. Okay, so you can also press this, okay, this knob you can also press in this direction, right? So middle pin is for the pressing of it, and plus is obviously for the VCC, and GND is for the ground, right? So this exactly how the rotary encoder works. So now let us have a look at this code of the rotary encoder which controls the servo motor. So I am defining the output A and output B pins as the digital pins and one servo motor. Okay. And counter variable will keep on increasing or decreasing as we rotate the encoder. And I am reading the state of the encoder using the output B. You can also read the state using output A as I have done in this code. Okay. So I will discuss this code later on. First of all, let's discuss about this code. And in the setup function, both the pins are defined as the input pins, and these two lines are related with the servo motor. So counter variable is initialized with value 0. And for the comparison of the state B, I am reading or storing the digital read of the output B in the B last state variable. Now here comes the important part. I am defining or initializing a if statement, right? In which B current state is not equal to B last state. Obviously, if we rotate the knob of this encoder, the current state and the last state of B pin will keep on changing. Okay, so this condition will execute only if we rotate the knob, otherwise it will not execute. So within this if condition there are more condition like if else. So if digital lead of output A is equal to B last state, right, then we are decrementing the counter, okay, on anti-clockwise rotation. So the counter will decrease as we rotate the knob anti-clockwise. And as we are controlling the servo motor, so you can also know that the servo motor cannot move beyond 0 degree, that means less than 0 degree and greater than 180 degree. It can only rotate between 0 and 180 degree. So if the contour variable is less than 0, we are setting it as 0, right? Otherwise, if we rotate the encoder clockwise, then we are incrementing the counter, okay, incrementing on clockwise. And if it goes beyond 180 degree, that means greater than 180 degree, the counter is set to be as 180 degree. Okay, so the servo motor will only rotate between 0 and 180, and we are writing that counter on the servo motor. Okay, servo 1 dot write, and we are printing the same on the serial monitor. And outside the if condition, we are updating the last state of B as the current state. Okay, for the next loop. So let us try to upload the code in the Arduino Uno, and let's see what will be the output.
So in this setup, the current state of the servo motor is 0 degree. Okay, we have set this in our program. If I rotate the knob of this encoder in clockwise direction, you can see the motor is also rotating. Now it has reached 90 degree, right? If I rotate further the knob, it will achieve the angle of 180 degree, and it will no longer rotate by or beyond 180 degree, because we have set the limit of this motor that after 180 degree it will no longer rotate. If I rotate the knob in the anti-clockwise sense, you can see the servo is again rotating in the opposite direction, and after rotating at that means after reaching at 0 degree it will no longer rotate. Okay, so the servo motor is constrained to rotate only between the range 0 to 180 degree, right? So that is the expected behavior of the program we have uploaded in our Arduino Uno.
So you will see this kind of output in your serial monitor if you try to run the code in your Arduino Uno. Okay, and after reaching 180 degree it will no longer increase. Okay, because we have set the limit to 180 degree. And if I decrease the reading by rotating the knob in anti-clockwise sense, you will also notice that it will no longer decrease beyond 0. Okay, because the servo motor is constrained to rotate only in the range 0 to 180 degree, right? So you can see the reading are not going beyond 180 degree and beyond 0 degree. So this code is very similar to the previous one, except that in this code I am using the output A pin to read the state of the encoder. Sorry. So this code is very similar to the previous one, except that in this code I am using the output A pin to read the state of the encoder, right? And the setup function is very similar to the previous one, except that I am replacing the B last state with the A last state variable. Okay, and these two lines are very important because the main changes happen in this on these two lines. You can see if A current state is not equal to A last state with the previous one, if B current state is not equal to B last state, right? B is replaced by A in this program. And in this condition, I am reading the digital read of output B, but in the previous one, I was reading a digital read of output A and comparing that with the B last state. But in this one, I am using output B and comparing that with the A last state, right? And obviously, the last line would also be different, that I am updating the last state of A with the current state of A, right? So now I want you to tell me that whether this code will work exactly as the previous one, or will there be any difference between both of the programs, right? So comment down below your answer and try to run this program on an Arduino and tell me what is the output, right? So let's end this video here and we will meet in the another video with new topic. So thanks for watching this video.